Hello, everyone. Welcome to our core protocol sync. Today, we'll be sharing updates from the last 2 weeks of core protocol development and maybe some plans for the nearest future. Shamil is not here today, so I think I will be sharing updates for him. Let me share the screen and I can walk you through what we've been doing because there were quite a lot of updates. Okay, I think you should see it. So there is a series of pull requests. The first one, the oldest one, was about persistence of providers. If you remember, in our protocol, we have distributed storage network, and we are announcing which pieces every node is storing, or like every participant on the network is storing. And we did it before with pushes, so we're just pushing data to other peers, and they were caching it, and that was fine. But that was using a lot of bandwidth, it wasn't very efficient. So we changed that to announcing that we are having something. However, we didn't store that information that we have announced something. So if someone restarts, they just forget about everything. So when someone reaches out to them asking who has this, they don't know. So this pull request basically adds persistence for that information, especially because that re-announcement happens every like few hours, so every day or something like that. It's very infrequent. So that is really crucial for network reliability. Any questions about this one? I will not go through all of the lines of code.
Yeah, how are these purged? Like, how
Yeah, there is
long?
expiration. So there is expiration mechanism. When you announce something, you announce it for a particular amount of time. If it's not re-announced in time, it will be just forgotten. But there will be some amount of stale records, of course. And there's also a mechanism for someone to announce that they are leaving the network, so you can delete it. I don't think we have that implemented, though.
And this is stored in the substrate storage layer. Is that correct?
This is, I think, generic. This is not just for subspace node of ARM. It's in the networking itself. So it's in both cases. Ivan, did you have something?
Yeah, I just want to ask, like, to double check, like, ask Shamil, because like I encountered bug during the syncing because I used like memory provided storage like from the Leap P2P one. So I used that and I got an error because like all the records were full, like it was filled during like after syncing like 40K blocks.
Yeah, it will be filled quite quickly. You should really use on-disk storage for the SDK. That is how it is supposed to be. And if you are using in-memory, it shouldn't fail. It should like maybe print some debug messages about that. If it's printing warnings, it's probably incorrect. But it act like LRU cache or something like that. It shouldn't like break completely. But it is bound in memory, just like it is bound on disk. But it will prune all the records, I believe, when it's full. But the size is like so big that we can store a lot of records, basically. They're really, really small announcements.
Mm-hmm. Okay. It works right now in SDK, so yeah, it's fine. Yeah. Thanks for clarification.
Okay. Let's move to the next one then. Yeah, piece receiving refactoring. This was basically a piece of logic we had in the farmer, but we needed similar kind of logic in other places, and this basically moves some of that logic into the networking crate, so it is reusable. It's basically just refactoring, nothing really special to talk about this. Yeah, then we had this interesting distinction on the networking level. When we are making queries for pieces, we could say that we want to get a piece from the cache or we want to get it from the archival storage. But the observation was that those nodes who are closer to the key on DHT, they should cache the information we care about. So if you ask them, they should know, they should either have it or they should know someone really close nearby in the academia metric that have it. So in that sense, it doesn't really, it's not really necessary to have the distinction. Just by proximity, we should extrapolate that they have it or they don't have it with high probability. So this pull request basically removes notion of two different kinds of requests, and we have just one. We just ask, give it to me, or like give someone who has it, And just from how far they are from the key, we can derive the priority from whom to download it. So it basically is refactoring, but it simplifies code quite a bit, which is always nice to have less code. I hope this makes sense. Yeah, this was superseded by another pull request, and this one I actually refactored a little bit, so I can show this version. Yeah, basically in the node, we had an experimental command in CLI, which allowed us to start a node by importing blocks from DSN. Or rather, it was like a command that you run to populate, like import some blocks, and then you can restart in regular mode to continue working as usual. But the bulk of the sync will be happening from DSN instead of from other archival nodes. So the first commit here basically moves all of that like importing logic into a separate module in the Subspace service from Subspace node, so it is reusable. It's just refactoring. There is nothing to look here. And the other two pull requests, two commits, the first one is just fixing some things. It wasn't quite correct after some of the networking changes. And the last one basically adds that special importing mode as one of the steps during regular mode. So you can just start a node and you can say it sync from DSN, and it will start syncing from DSN first, and then it will continue working as usual. So it kind of combines both modes together in a nice, easy to use way. And it is done basically with the if statement in the service, I believe. Here, if we specify CLI argument sync from DSN, it will connect to DSN. It will try to import as many blocks as there are on DSN, and then it will continue as usual. It is not quite full integration, because if you need to do keep up sync, it will still happen from archival nodes or other nodes of the network. But at least the bulk of the initial sync, like from Genesis, it will happen potentially from DSN. This is something we'll be testing more over time, but this is like MVP. There is no piece verification yet. This is something Shamil is working on and has pull request open for. And there are some other improvements, but this basically is one step closer to resolving Farmer's Dilemma. And this is really, really exciting, because we didn't have it up until that moment, before this pull request was merged. Any questions, comments about this?
Hey, I have one question, because I've been looking at the Substrate code with reference to the block optimization stuff I'm working on. So there, they have this import mechanism which is used quite a bit. Right, after a block is announced and so on, they Substrate basically imports a block into its storage. So I was wondering like how that is connected to this importing that we do, or are these like different things even though names are same?
It is kind of related. So making a step back from where we have taken inspiration from, basically in Substrate CLI already there are commands to export blocks and to import blocks, and you can export them into binary or JSON format, and you can import from the same file. So you can basically like back up basically your chain. What we are doing here, we are doing essentially the same thing, but we are taking blocks not from the file. We are like assembling them on the fly from archived segments of the history. So we're just reconstructing blocks and then importing them one by one into the chain. And we are assuming that whatever is archived is on canonical chains, so we don't need to care about forks and such. So it is kind of related in that sense. It's the same API. However, what you will be doing is, I think, even more low level, because you want to like not have the whole block necessarily. And in some places, Substrate is not quite flexible to that degree yet. So that is a little bit more complex than this. This is quite simple. Okay. And yeah, we had this data structure which I refactored in one of pull requests I will show later. And Shamil just changed the parameters to not be Kademlia specific or peer-to-peer specific, to be generic. We can reuse just generic key value store based on parity DB in many places. So it's relatively simple refactoring. Okay, that's about the work Shamil was doing. What I was doing. First of all, we had some unnecessary code around timeouts. Basically, in lib peer-to-peer right now, there is no really way to start doing something or like invoke I want to do something and then just cancel, like you change your mind. So when we had those timeouts, when something was happening really slowly, what we were basically doing, we were making things worse by timing out and then starting again and timing out, starting again. It was just self denial of service basically. It needs to be fixed eventually in upstream. And there were actually reasons to have this because some of the things were failing in the older version of lib peer-to-peer. But since we fixed the concurrency thing, it doesn't fail. It just happens later in some cases when there is a big queue. So by removing these timeouts, we fix some of those problems. And we basically wait for lib peer-to-peer to either give us the result or to give us an error. But either way, we need to wait until it finishes. And that's what this pull request does. It just removes a few lines of code, and it's really quite simple. Okay. Then this was just a warning we have seen after we deployed the Gemini 3C. It wasn't really necessarily a warning, so it was made a debug message. Then there were a few refactorings I was doing. The first one was, let me see. Yeah, one of the interesting changes in this particular pull request, I think, is that the way we were doing like processing announcements was quite heavy. So basically what we were doing when we get an announcement from someone on the network, we check. I don't remember if you even check. Let me see. Yeah, we didn't really even check. What we were doing, we were requesting to get that announced piece from others. In order to do that, we were doing lookup for the closest peers to the key, and then we were picking one or iterating over each one by one, and then we were getting the piece, and then we were deciding if that's something we want to store. That was like really long and heavy process, unnecessarily so. Through many of these pull requests, there were like 4 in a series. That was basically simplified to first check if we need to store it, because in some cases we have already plotted that piece, which means it is already announced. We don't need to bother at all. In some cases it is cached, so we have received announcement earlier, in which case we also don't need to do anything about it. And even if we need to do something about it, we can't just request the piece from the same peer that has just announced it to us, because they should have it. They just did announcements, right? That makes sense. Rather than doing lookup for closest peers and so on, which decreases the time significantly and improves the performance of DSN in general, because we are not doing as much stuff as we did before. So that's, I think, one of the biggest changes here. And also towards the end, the announcement processing was done, was made such that it is allowed to have concurrency. And in this case, it's 20 announcements can be processed concurrently. The assumption is that many of the announcements are just quickly checked and there is nothing to do. So we can move through these very quickly. And those that do take a few seconds, they will be processed in parallel. And that should also improve things quite a bit. And from what I remember, Shamil said that it looked quite good to him. Yeah, major improvement in performance. So that was nice. And there were also some refactorings along the way to fix some of the expects that were not necessary, or like not really expects that were potentially panicking, and there are some other improvements. Questions about this part? Okay. Then there was a second part. I was just splitting them into more manageable chunks because they were big. Yeah, this basically introduces some of those checks that we don't announce something that we have already announced. There were many aspects to it. One is something that we have received announcement for and cached. The other thing is something we have plotted. There are like multiple places where we need to check these things. And this pull request was basically doing that. And it was doing also some refactoring along the way and simplification. For instance, we had this shutting down variable that was internal, and then it was exposed, and then this pull request became internal again, and then we got rid of it eventually. So I don't know if there is anything in particular I want to talk about here. If you care about details, you can go through description and individual commits. All right. Then I just noticed when I was doing that, one thing that in the Leap peer-to-peer, there is a way to create, not Leap peer-to-peer, in the Schnorkel library that we are using for keys, there is actually a way to get the secret key transformed into ED25519 format. And there is like a special function for that that has some extra things. And what we were doing before, we were just converting to raw bytes, and we were interpreting that as ED25519 secret key, which, from what I understand, I'm not a cryptographer, is not exactly correct. So this is a simple thing I have found, and also there are some expecs which are not actually correct. So this simplifies it, and it's panic-free at this point. Then the third pull request that was refactoring. Let me recall what is there. Yeah. Again, basically refactoring, more checks. I don't think there is anything in particular I want to talk about here. It was just part of a bigger initiative. It did fix this one. Yeah, okay. Yeah, there is one thing I want to talk about. So in some places we have channels in APIs which are really cumbersome to work with. One of the reasons is that we want those channels in most cases to be bounded in size. And that means that if you are pushing something, it will be just accumulated, and at some point it will be full. You need to either handle warnings or errors, or you need to stop everything. And in this particular case, API was really not misuse resistant, in a sense that we have been creating in the node internally a channel, and we were pushing announcement messages in there, and we were expecting for someone to come later and call this method take provider records receiver. But you can only do it once. Then receiver is gone, and next time you call it, there is no receiver anymore because it's a multi-producer, single consumer kind of channel. Also, if you don't call this, it basically means that node will internally accumulate those messages until it reaches the capacity of the channel, at which point it will start printing warnings, which we have seen more. We have seen a lot in the testing of Gemini 3C. So this has been changed to this kind of Node.js style event handling, where we basically have a way to subscribe to announcement messages, and we can do it once, we can do it 10 times, as much as we want. And if no one listens for this, then nothing is basically leaking memory. And in the farm itself, we do care about it, so we have created a channel here instead, and we have full control over it. And in this sense, API is more resilient to memory leaks and other things. And we have this API for many things. So we had this subscribing for a new listener interface. When you have a new network card plugin, peer-to-peer will start listening on it. We can capture that event, and we can like print something or tell someone that we have this new interface. So we have just added another announcement subscription of that kind. And I would prefer us to have that in many more places. It's not super convenient in some cases to use, but at least it fixes the problems and make it more decoupled. You can subscribe and unsubscribe anytime you want. But you need to either store the handler returned from this announcement, or you need to detach it so it's not unsubscribed immediately. But it will print a warning if you don't care, like with features, if you don't wait on it. So I think that's the only thing I want to mention here. Does it make sense? Okay. There is another fourth pull request in this refactoring. And this basically ties everything together and fixes another issue that basically in some cases when we are plotting, we already have something either in our plot in another sector, or we have it cached because we are close to the key. So when we try to plot something, it would be better if we just locally resolve that piece and didn't reach out to the network in the first place. So this pull request, based on all of the previous refactoring, basically made it such that when we do need to plot something we already have, we just take it and we don't make network requests at all. And that was only possible after we did decoupling and refactoring in the prior pull requests. Yeah, and I gave some notes to Ivan about how to use it properly, because you can use it or you cannot use it. It's like up to the user of the library to do that. And with all of that done, this is just a tiny refactoring, not worth talking about. With all of that done, this is the pull request where it was going, or which was made possible. Basically, there were a lot of things refactored, but they were contained in the binary part of the farmer. And farmer, we have library and binary, like executable part of it. So this pull request basically moved a lot of those things and refactored further to expose them as a library. So SDK doesn't have to copy paste all of those modules and make modifications. It can just use them as is and maybe create a wrapper in some cases, because on the SDK side, we have node and farmer in the same executable. So we can not only check the cache of the farmer, we can also check recently archived pieces of the node, and we can pull pieces from there if they're present. So it's even more efficient. So yeah, basically this pull request does that. And there are also some steps for you on how to take advantage of that. I don't think there is much to discuss here. Yeah, and this is the pull request we already talked about. That basically Shamil did the work. I just refactored it, restructured pull request a little bit. There is another pull request from Shamil, as I mentioned, that will make further improvements to the block importing through DSN, but I think we'll talk about that next time once it lands. With that, I think that's the recap of what me and Shamil were doing last 2 weeks. Do you have any other questions about that?
I'm
Okay, so I
curious,
have one
Ivan, were you?
question. Sorry, I have one question about the previous thing you mentioned about the Node.js style thing, right, to replace MPC channel.
Yeah.
So how is this different from the one-shot channel that Tokyo has, for example?
One-shot channel just gets one message through. In this case, you can subscribe and you can receive messages many times. So every time there is an announcement, you will get a message. And you can either process it in place, you can send it to another channel, you can print a message and be done with it. You can do whatever you want.
And I was asking,
Jeremy?
Ivan, were you able to get use the new API, or are you still working on that?
No, it's already integrated into the SDK. So yeah, even the importing importing blocks for node from DSN is also working.
Okay, great.
I mean, I haven't tested, but I integrated
it.
Should work.
We're not sure it's working, but should work.
Okay, with that, Rahul, can you share what you've been working on?
Yeah, so I've been working on the design proposal for the block optimization, where we don't have to, since we already broadcast the transactions, we want to avoid putting rebroadcasting them as part of the blocks when we announce blocks and so on. So that's what I've been working on. There are two parts to it. One is the kind of more researchy side, where we looked at like different schemes, potential schemes, like things like I've been looking at like compact blocks that's already used by Bitcoin and others. Then there's a new thing called graphene. Then Bitcoin also has this other thing called extreme thin blocks that also I kind of looked into. And there are a few other new research papers that were published in the last 2-3 years, but those are like too early to use. So right now I'm kind of leaning towards using graphene or extreme thin blocks. Graphene is kind of more involved in the sense it may need like more handshake between the two nodes to synchronize, but it gives us like a very good savings in terms of bandwidth. And there's another research paper which was published which compares all these different schemes. Like a third party ran some benchmarks on all these things, and they also found like graphene like outperforms all other schemes. So I'm writing a Notion page with all the findings. So that is the part one. The second part is the part where I'm trying to figure out the implementation details. That's why I've been kind of reading, experimenting with the substrate networking / consensus layers, how they do the block announcements and so on. I'm finding like it's going to be kind of a fairly invasive change in the substrate layer, because right now everywhere it's assumed like the full blocks are gossiped, and they have this simple request response handshake mechanism for downloading blocks. Like when a node announces a block, it sends a simple request to the other node, and it's responded with a full block. So I'm looking at different ways we could address this so that we can experiment with these new schemes. So what I would like to do is like make this block relay layer like modular, just like in other places. So we can replace any scheme as we choose when we want to do the block relay. So I kind of identified the or localize where in the substrate code we may have to make changes. That kind of touches the transaction, the mempool, and the consensus interaction, and the network interaction. So I hope to come up with a more concrete proposal in the next 2-3 days and put that in the Notion doc. So that's the main thing I've been working on. Ideally, I would like to do a prototype where, with this new framework of modular block relay, the existing thing works as is. So what that means is like the existing request response full block thing will also become another scheme, except like the rest of the code doesn't have to change. So if we can somehow make this work, that will give us confidence that we can do modular block relay going forward with the new schemes that we have under consideration. So that is my immediate plan. And I also work with Daria on Friday to understand the consensus read 2.3 changes that would be needed from me in terms of the C KGG libraries and the Chia library. Now I think I understand 2.3 better, and Daria kind of walked me through the immediate requirements. So once I'm done with the block proposal work, I plan to start working on the 2.3 changes. This will probably help Nazar and Daria in the stuff they're doing on the consensus side. So that's it from me.
Yeah, on the networking and sync and announcement side, I was looking into that a few months ago as well. And I have discovered that the sync mechanism and networking, they're basically one thing, like big monolith that needs to be sliced into different pieces. And I was doing some of that work upstream to the point that we are basically able to swap the networking layer entirely as long as it conforms to their API. It's not like super flexible, but it is, we can like wrap it if necessary. And there was also a lot of other work happening after that by other people in the community that extract sync mechanisms specifically. So basically, there is a chain sync, I believe, data trait there that you can potentially wrap, and like before encoding, you can like extract some, like remove something from it, or like replace transactions with hashes, and then you can reconstruct them on the other side. So like you can at least wrap it and intercept some things at this point, but it's not quite as flexible as we would like, maybe.
Yeah. Thing is, the chain sync also has a lot of other functionality that we don't want to reinvent. So there is one particular place where the request is broadcast and the response is received. I want to just modularize that part so that the rest of the chain sync doesn't have to change. I think that will be the ideal point, because we don't want to retest a lot of things, the rest of the networking layer. So that's what I'm trying to do right now. So just modularize only the handshake where the block announcement is sent and the request is sent and so on.
Yeah, so that makes a lot of sense. That's kind of where I was going with that refactoring, to make at least that possible. Because replacing everything with custom implementation is really a lot of work.
Yeah, it's a lot of actually it's a fairly complex code base. I was trying to read through it. There's a lot of stuff there. So yeah, I don't want to touch the remaining part of Substrate. Do only what is required, I guess. That's it from me.
Okay. Any other questions to Rahul? All right, let's move into research. Daria, there was quite a lot of things happening on your side as well.
Yes, there has been So one of the main responsibilities is in maintaining the specification. We have managed with Chan to finally address and close all of the open comments and questions. Some of them were either, added as changes to the spec, where some places where we need to XOR or hash and the explanations to why those choices were made in particular places. In some places, I have just added the notes to something that we might have to look at when we actually get to implementing it, because it's not. Some of the things are not really possible to say right now, and I need to look more into it. And some of that also depends on the what is it CKZG can provide, or the Chia library that Rahul will be looking at. So that's that. And the biggest part of my work is I've been working on the slide deck for a presentation that I will be giving this week to the engineering team and the wider team about the new consensus. I have finished 2 iterations of the draft, and I'm working on hopefully the final iteration before the presentation. And in the meantime, after addressing everybody's suggestions, well, everybody's was Jeremiah, Cesar's, and Chance, it has doubled in size. So I'm actually writing. I decided I should have write everything down, because if I'm going to be speaking from my mind, it's never going to be able to finish it in 1 hour, the talk. So hopefully that goes well, and this is what I'm going to be working on in the immediate future. And I have met with Rahul and walked him through the consensus, as he already mentioned.
Okay, that's quite exciting, the presentation. I think we will be sharing that with the community as well, I think.
Well, we'll be recording it, and Yaser will be sharing that, or we'll
Mhm.
be recording another one. Yeah, we'll see.
Yeah, I don't think we had a lot of public information about how that consensus actually works. So this might be some really exciting new information for the community to see. Okay, any questions or comments to Daria's update? All right. Anything else we need to discuss before we wrap this up? Okay, I think we're good then. Thanks everyone for watching, and we'll see you in 2 weeks with even more cool updates.